Hello, I'm Eric Snodgrass, and thank you for watching today's midday weather outlook for the southern region brought to you by Nutrien Ag Solutions. Well, here we're looking at the last 48 hours of total accumulated precipitation through early in the morning on Tuesday. We can see that there was some widely scattered, but at times very heavy rainfall from some of these thunderstorms. And what I want to do at the beginning of this video is kind of diagnose the typical precipitation regimes we have across the south as driven by the frontal systems we normally see. And then we're going to take a look at how we expect that to evolve over the next at least 15 days here, okay? So we're going to start off here with the satellite animation from midday yesterday until sunset, and we can see the storms exploding right here in this part of Texas on the dry line. And some of the storms were locally able to put down quite a bit of very heavy rainfall. Now, the position of that dry line, which is the boundary between where the Gulf of Mexico moisture runs into the dry air here that comes off of the desert southwest, off of the mesa, off of the higher elevations of New Mexico, well, where those two boundaries collide, where those two air masses collide, you get a boundary. And oftentimes some of the world's most spectacular thunderstorms form on this. And we're going to talk about the southeast in just a few moments, but I want to show you kind of what I'm talking about here. So yesterday afternoon, this is where we can see the collision of those two air masses. You're looking at a map of dew point temperatures from our high resolution model called the NAM model. And you can see we were getting an abundant amount of Gulf moisture that was coming out to the east. You see dew points there in the upper 60s to mid 70s. In fact, as you get over to Louisiana, parts of Oklahoma, and even into Arkansas, we saw dew points climbing up almost to 80 degrees Fahrenheit. But if you look right on the other side of this line, of course, the dew points are incredibly low. So very hot and very dry conditions on the back side of this, where around Amarillo or Lubbock, we're talking about upper 30s, lower 40s for dew points. Well, when that very warm, moist air collides with the very dry air on the back side, even though their temperatures are the same, the densities are different. And I know this is going to sound a little bit counterintuitive, but the air with more humidity in it actually has the lower density. Okay, and that's because when you introduce water vapor, the molecular weight of water is 18 grams per mole. So when you replace some oxygen or you replace some nitrogen, those are the other two main gases in the atmosphere, with water vapor, you actually reduce the density of the air. Now, I know when you're in high humidity air, it feels as though it's more dense, but that's because the body cools by sweating, and therefore, as a result, you feel like you're swimming through really humid environments. Okay, so it's kind of a neat bit of chemistry there, but that's how that works. So that's why the warm, moist air runs up over the dry and blows up those huge thunderstorms. Now, as you get east of there, the entire atmosphere was just humid. And this rapid satellite animation here is in parts of northern Georgia, Alabama, and Mississippi. And what you see here are just the storms that just popped on the heat of the day. Now, what's neat about these storms is that as they form, they produce their own outflow. So you can actually watch. Let's just get a good storm here and see some of the outflow pop out of it. Okay, see the storms that are right in through here? They're about to kick out a little ring of clouds around them. You can almost see it right here. And that outflow acts as a mini cold front which spawned the development of that thunderstorm. And they just kind of do this. They all kind of get daisy-chained together throughout the day, forming on their own outflow. I anticipate something like this to continue to happen for quite some time. Now, take a look at this. This is the all hazards weather map released early this morning. And while we do have red flag warnings here, we are starting to see our heat advisories crank up in the midsection of the United States. But you notice there's a very fine boundary between where the heat advisory sits. And guess what? It's going to sit right on the dry line. So later on this afternoon, this is from our high-resolution NAM model. What we can see here is the position of that dry line. So it sits right in through here. And on one side of it, the dew points are very, very low. So we're getting high evaporation rates under the heat here. But on the other side, where we have all the humidity in the atmosphere, well, this is where the atmosphere is going to be primed for thunderstorm development. Now, let me show you another quick animation. This is looking at what we call the apparent temperature. It accounts for how quickly the body can cool itself with evaporative cooling, in other words, sweating. Now, what you're going to notice is the highest apparent temperatures, or it's more commonly called heat index, right? The highest heat index values are going to be where that high humidity air sits. So as I played this forward, you'll see these numbers really crank up here as we work our way through the day. 110, 112, 115, and when the storms pop in that humidity, you can see it really rapidly cool off. Well, that's just the outflow of the thunderstorms cooling things down. So I just wanted to take a moment and kind of show you what I find to be really fascinating meteorology here. Because as we watch today's winds, you can see the Gulf of Mexico moisture transport here. You can see the dry air coming out in this area, and the boundary sits right in between the two. That will be where our storms find fire. Meanwhile, over here in the southeast, under generally higher atmospheric pressure, all we're going to get is pop-up thunderstorms on the heat of the day. So that's it. That's a really cool way to look at it. Now, over the next week, we're going to be noticing that those pop-up thunderstorms are going to become a bit more organized as you get into the southeast, as this higher atmospheric pressure cell builds into the Great Lakes states. And what it's going to eventually do here is it's going to leave a boundary, like right in through here, a frontal boundary on which storms are going to repeatedly form. Now, what I want to watch for is on that frontal boundary for lower atmospheric pressure to eventually form here and then move its way just offshore. We could be seeing maybe some tropical development as this moves away from the United States. But as this overall pattern evolves, we will see in the upper levels of the atmosphere really not conducive environment to developing thunderstorms here as we get back into the western side of our southern region. And so I'm going to be talking at the very end about what I expect in terms of drought expansion in the south central part of the United States. So let's watch all that unfold. Ready? So this is early this morning. Let's click play and we'll pause it and walk you through some of the details here. So as we work our way into Tuesday afternoon and evening, again, you see the storms popping on the dry line here, but we see general scattered storms all over parts of the southeast. This again is this evening on Tuesday. Working our way into Wednesday morning, afternoon, and evening. Again, we're going to watch for storms right here Wednesday evening, but you see the scattered nature of the storms in the model in this area. So when does the kind of old pattern start to shift? It starts to shift once we get into Thursday afternoon and evening. Now at this point, higher atmospheric pressure begins to form right in through this area. So you can see all along its periphery right here where we're expecting storms. So this will be where that stalled out boundary is going to sit, okay? Still could watch for some storms to pop over in parts of Texas, but it's going to be hit or miss, and some of these storms can put down better than a half inch of rain in 15-20 minutes, and some of them will completely miss people on the other side of it. So this is now getting ourselves into Friday morning, afternoon, and evening. Now at this particular time period, as the higher pressure settles into the Great Lakes, you'll just see general storminess all around this area. See it here? So the farther north you go, the drier it gets. It'll be right around the edge of that high pressure cell sitting in this area. So this is now Friday evening, getting into the overnight hours and working our way into 4th of July Saturday. So I expect to see a whole lot of, we always joke, but it's true, a whole lot of natural fireworks right into this area in our southern region on Saturday afternoon and evening. Now after that, on that boundary, do you start to see the low pressure cell forming here? This could take shape Sunday evening and pull across parts of southern Georgia, hitting some very productive peanut and some cotton fields down here, and other crops. And this is going to move towards South Carolina early next week and then pull out here into the Atlantic. And that could be what we see in the development of that tropical system that I mentioned. But I'm already more than a week out in the forecast with an operational model, and that gets to be where it loses some of its confidence. But you can see here that the prediction of some lower atmospheric pressure and the eventual track of that low pressure moving here off of the coast as we look out into next week. So we're going to keep a close eye on that developing here because it could bring some very locally heavy rains to this area. No, it is not set in stone, and we've just started to pick up on this just in the last 2 model runs. So we're going to watch it carefully as we progress forward with this. Elsewhere in the Gulf, or not in the Gulf, but in the Atlantic, did you notice how we didn't see much developing here? We keep seeing these little systems attempt to pop up, but they really have a tough time surviving. And it just comes back to this idea of how dry and dusty that air is. So let's take another look at our next dust plume that's coming into the south, and it's starting right here late last night in the Caribbean. As we play this forward, you're going to see throughout the day today that dry, dusty air kind of move its way into parts of Texas and Louisiana. And while this doesn't look anything like the dust storm we saw last week, this is still quite a bit of dry, dusty air in the Saharan air layer. And it's an important feature as we look forward to what this tropical system or season is going to be giving us. Now, getting out to day 10, the jet stream pattern is advertising a very interesting situation where we have a trough here, and a trough there. Do you notice that? And then we have generally higher atmospheric pressure on either side of it almost. Now, across North America, it's going to be these 2 troughs, the ones I've left labeled here, that are going to dictate our pattern, because it's in general going to do something like this. Now, what's interesting is the feature that comes down here. Do you see that? So part of the jet stream is going to run over the top of it, and we're going to have another piece of the jet stream cutting down into the southeast, and that's going to be important for temperatures. But in general, in the mid and upper levels, higher atmospheric pressure is going to sit over parts of Texas. Now, what's that going to do? Well, it's going to do this to our upper level flow pattern. At times, we will be seeing weak mid-level high pressure cells that will sit over parts of the south. But what will end up happening around them is we'll get moisture transport. We will at times still see quite a bit of thunderstorm activity in and around the southern portion here of the United States. I'm watching for anything that permanently shuts down the Gulf of Mexico transport, and I keep seeing these high pressure cells are a bit more transient. But what we end up getting out of this is that general thunderstorm type pattern in through this area, and then north of it, very dry conditions. Can you see that? And then all around, remember, if you remember that pattern doing something like this, just to kind of show you, we're going to have an unsettled pattern here in the northern plains getting back into the Canadian prairies. But in between the two areas, much drier conditions. So those dry air that we've had in place here, I don't anticipate much relief at all in that as we work our way into the middle part of this month. Now, what are temperatures going to do in response? Well, this is actual temperatures, not apparent temperatures. We do see the triple-digit heat spreading from Texas and Oklahoma and Kansas today, and above average temperatures in the southeast as well. Why the cooler weather on the northern edge of our southern region here? This is due to a lot of thunderstorm activity throughout the day today. So you're wondering, is this cooler air going to get here? And the answer is no, it doesn't. Watch, it just stays out west. By the way, it's kind of amazing to think that 99 degrees here is about 9 degrees colder than average in parts of Phoenix. But as we play this forward, let's get into the day on Wednesday. Another very, very hot day in the south central plains. Working our way into Thursday, same story. Look, now we're in Friday. Not much of a change at all in the next several days. By the way, these are your high temperatures on the 4th of July. Again, at this particular point, we have remember the storminess we expected down here? So that could keep temperatures near average or cooler than average with cloud cover, but still very hot in parts of Texas, working way up to Kansas. As we go from there into the day on Sunday and eventually next Monday, at this particular point, this is where the jet stream had this feature, right, that kind of cut around back like this, and so we could get slightly cooler than average temperatures here across the southeast as we work our way into early next week. It's picked up with the longer range model outlooks as well. This is day 5 through 10 from the European. I think the European has the best handle on this pattern. So you can see the area I've circled experiencing near average temperatures into that 5 to 10 day time period, which gets us out to July the 10th, and then warmth all around the periphery of this. And so that's what we're anticipating in terms of our temperature patterns out to that length, and then all the way out to day 15. Just to let you know that at this point, the atmosphere is really relaxing the position of the jet stream, pushing it north. We're expecting much of the United States here to experience above average temperatures. So my concern is really right in through this area, because at no time in the next 15 days am I expecting anything like cooler weather to exist in there. And our problem is we have already lost quite a bit of soil moisture in this area due to the expanding drought we've seen now since May. And with that expanding drought, remember that if there's moisture in the soil, 50% of the sun's energy can go in there and evaporate that moisture. And then that means only 50% goes into heating the ground. Well, with a lack of soil moisture, we're just pounding this with solar radiation. And as a result, it's going to get very hot. So I expect to see a lot of triple-digit heat here all the way through the middle of this month. So we're really going to make some changes in the maps I showed you yesterday of where we've already experienced those 100-degree days. So that's what I've got for you, and I will be releasing later on today a new long-range outlook that discusses where I think this pattern is going to continue to go for July and beyond. So take a look at that. One other thing, I'm going to go on a family vacation, and I'm going to just hold off for the next 10 days or so on making my regional forecast videos. I'll still make the national ones and the long-range outlooks, but I'm just going to take a little bit of a break here, and I'll come back on it and get going again once I get back from that vacation. So I appreciate you all giving me that time. It means a lot to me and my family, and I look forward to providing you forecast information for the rest of the year without stop, okay? Have a good one. Thank you so much.